Hello gems, welcome back to another video. First of all, a very happy new year, and today we'll be discussing mock test number 3 for JEE Mains 2023. In the previous two videos we discussed mock test 1 and mock test 2. If you have missed those out, links are available in the description box of this video. So it's new year, new you and me, but same dreams. I know that does not rhyme, but let the grind begin. Question 1 and 2 over here. In question 1 we are given the efficiency of a Carnot engine by this formula. We are told that alpha and beta are constants. Mind you, they are dimensional constants, which means they will have some dimensions. Then later we are told that the letters have their usual meaning. T is for temperature, K is for Boltzmann constant, theta is for angular displacement, and X has the same dimensions as that of length. Okay, then here you are supposed to choose the incorrect option. Okay, so read the question properly. So here you are supposed to select the option which is incorrect, which is not correct. Okay, so first of all we can notice that this is within log, right? Whenever you take log of something, that something should be a pure value, right? So this term inside log, okay, that should not have any dimensions. Okay, so basically when you take log of something, that something should be a value. Okay, so it should not have any dimensions, which means that the dimensions on the top, the numerator and the denominator, should be equal, so that they cancel out each other and the thing that is left is just a pure value. Okay, so dimensions of beta x should be same as dimensions of kt. Okay, now do you know the dimensions of kt? It can be easily found out using the equipartition law. It says that energy is 3 by 2 kt, so you can clearly see from here that kt has the same dimensions as energy, right? So kt will have the same dimensions of energy, so m L2 t raised to minus 2, right? mv square, right? So m L2 t raised to minus 2. So beta x will have the same dimensions as kt. Okay, and x has the dimensions of length, so you can substitute that. This L and this L will get cancelled. So dimensions of beta is m L t raised to minus 2. Okay, if you see, these are nothing but dimensions of force, right? Mass into acceleration, m L t raised to minus 2. So beta has the same dimensions of force, but you are supposed to select an incorrect option. Okay, so don't be impatient, read the question properly. Okay, so this is correct, so which means we are not supposed to select it. We are supposed to select the incorrect one. Okay, next let us find out the dimensions of alpha. So if you see over here, on the left hand side we have efficiency. Efficiency is just a number like age, right? So efficiency is just a number. So if you see the right hand side, we have alpha and beta. Beta has this dimensions, right? All of this is dimensionless. If you see log of something, dimensionless, this is a value. Log of that value, dimensionless. Sin theta, dimensionless. So this alpha into beta should also be dimensionless. Okay, so alpha into beta should be dimensionless, which means m0 L0 t0. Okay, so basically this means that your alpha will have dimensions same as that of 1 by beta. Okay, so they will be reciprocals of each other. Okay, so that their product becomes dimensionless, m0 L0 t0. Okay, so alpha and beta their dimensions are reciprocals of each other. Okay, so if you see, okay, we cannot deduce anything from here. Actually we can. If you see, alpha inverse x has the same dimensions of energy. If you see, alpha inverse is nothing but beta. Beta into x is energy, right? Beta into x is kt, which is energy, right? So this is also correct, which means we are not supposed to select it. Okay, yes, you get the rule. And here we have the dimensions of n inverse again, efficiency number, sin theta number, dimensionless, is same as alpha into beta. Alpha into beta, dimensionless, I told you, right? So this is also correct, which means it's not the one we are supposed to select. We are supposed to select this one. You can see that dimensions of alpha and beta are not equal. They are reciprocals of each other. Okay, they are not equal. Okay, so this is the incorrect one, which means technically it is the correct one, since we are supposed to select the incorrect one. Okay, no more confusion over there. Let's begin with this one now. So here we are given the position of a particle. So it's moving actually in xy plane, and it is maintaining its z component, the z height, which is called over here. It is maintaining the z coordinate constant. Okay, so the position along x and y is given by this. So this is position along x and position along y at any time t. Okay, you are supposed to tell the acceleration of the particle. So we'll divide it into three parts, x, y and z. Okay, so in the x direction we have the x coordinate. X coordinate is given as x is equal to 3t. Okay, so velocity will be given as take the derivative of this dx by dt, right? Velocity. So here the derivative is 3. Acceleration, if you want, in the x direction, okay, so it will be 0, right? 3 is a constant, and if you take dv by dt, which is acceleration, that will be 0. Now let's come in the y direction. So y, we have the position is given as phi t cube, right? So phi t cube, differentiate that so that you get velocity in the y direction. This is all in x direction, this is in y direction, okay. So velocity in y direction, so derivative of that 15t, right? 15t square, okay. 3 will come down and 3 minus 1 on top, right? So again, if you differentiate that, so acceleration is dv by dt. So again differentiate, so that will be 30t. And you are supposed to find acceleration at t is equal to 1. Substitute t is equal to 1 over here. So the acceleration in the y direction is 30 meters per second square, or here it is in centimeters, so centimeters per second square. And here z, in the z direction we are told that the z coordinate is basically constant, it is 7 throughout. So velocity will be 0 when you differentiate that, and again acceleration will be 0. Okay, so there are no contributions from the x and the z direction, only contribution is from the y. So acceleration vector, actually it will be given like this. Here we are using xy cap, so xy. So if you had all the components, it would have been given like this, okay, in general way I am writing, okay. But here acceleration in the x and the z direction is 0, only the y component is surviving, which is 30. So 30 in the y direction, which means y cap. Okay, so 30 y cap. So option B is correct over here. Okay, I hope the approach is simple. Let's move to the next set of questions. Question 3 and 4 over here. In question 3, we are going to shot a bullet. Nobody was hurt during the making of this question, except the JEE aspirant who is answering this, of course. Anyways, the bullet has a mass of 200 grams and initial kinetic energy of 90 joules. Okay, it's shot inside a long swimming pool. Okay, and the kinetic energy reduces to 40 joules within 1 second. Okay, inside the pool due to the force on it. Okay, so you are supposed to tell the minimum length of the pool for it to come to rest. Okay, so pretty straightforward question, actually a standard question. You can use the idea of actually work per energy, but I think we'll use simple kinematics since time is given and that might complicate things. So we'll proceed through kinematics. Okay, so first of all we'll find the initial velocity. Okay, we are given the initial kinetic energy as half mu square is 90 joules, right? So from here we can find the initial velocity. Mass is 200 grams, so 10 to the power minus 3 u square. So this is 90. Okay, so I think this is 0.1, right? So this is 100 and this is 10 to the power minus 3. 0.1 goes to the other side, becomes 10, so 900. So u square is 900. Okay, so u is 30 meters per second. So similarly we can find the final kinetic energy. Okay, not actually the final, the kinetic energy after 1 second, which is given as 40 joules. Okay, so here again this m by 2 will become 0.1 as we know. So 0.1 goes to the other side, that becomes 400. So v square is 400. V will become 20 meters per second. Okay, now the entire point of finding this and this, the velocity after 1 second, and this is the velocity initially, okay, when the kinetic energy is 90 joules, and this is after 1 second, is to find the acceleration. Okay, we are assuming that the acceleration will be constant, so acceleration will be change in velocity by time taken, right? So change in velocity, final velocity minus initial velocity, you can see that it will be negative, of course, because the velocity will be in one direction and the force or the acceleration will be in the other. That's why the bullet is coming to rest, right? So this is the change in velocity by time taken is 1 second. So the velocity is minus 10 meters per second square. Okay, now this job is done. We have found the acceleration. So we have the initial velocity, the acceleration. This is the velocity after 1 second. Okay, 1 second. that's of no use. We used it just to find the acceleration. Okay, so we have initial velocity, acceleration. We know that the bullet should come to rest finally, right? So the final velocity will be 0, right? So we can use the relation v square is equal to u square plus 2as. Okay, because we have u, we have a, we want to find s, v final velocity, the bullet should come to rest 0. Okay, so v is 0, u square initial velocity square 900 plus 2as. So 2 into minus 10, so which is minus 20. Okay, and into s we are supposed to find. So if you take it to the other side, this will cancel, and 90 by 2, which is 45 meters. Okay, so 45 meters, which is option A, right? So 45 meters is the correct choice over here. Let's come to this one. Okay, so here we have two clocks based on the principle of simple pendulums. Okay, the two simple pendulums are identical. Okay, which means they have same mass, although that does not matter. They have the same string length, that matters. Okay, so clock 1 is placed on Earth and clock 2 is placed on a space station. Okay, the space station is at a height h. H is of course measured from the surface of the Earth. Very important point. And clock 1 and clock 2, so clock 1 on Earth has a time period 4 seconds, clock 2 in the space station has time period 6 seconds. Of course, right, the time period will be more because gravity is less. T is inversely proportional to square root of g, right? So at the space station the time period is more since the gravity is less. Anyways, we are supposed to find the value of h. Okay, so as we said, time period is inversely proportional to square root of g. T is equal to 2 pi under root L by g. So it's inversely proportional to square root of g, and g, as we know, is inversely proportional to r, right? We can write g as gm by r square. R is the distance from the center. Mind you, you cannot use the relation gh is equal to g into 1 minus 2h by r. Okay, this is a relation which is only valid for h which is very much lesser than the your radius of Earth. Whereas if you see the values of h over here, these are pretty much comparable to this. Right? This is 1/4 of this. This is also some factor. Okay, this is twice. Sorry, this is half of this, and this is also 3/4, I guess. Okay, so it's this heights are comparable to this, so you cannot use this formula if you were able to use. Okay, so here you can see that g, so we are going by the standard approach, that g is inversely proportional to r square. Okay, r is distance from center. Okay, so actually you can rearrange and see that you can take square root on both the sides. So square root of g is inversely proportional to r, right? Once you take the square root, and you can interchange now. So r will be inversely proportional to square root of g. Okay, I hope that's clear. So we took square roots and just interchange. Okay, so r is inversely proportional to square root of g. So again, you can replace that square root of g by r. Now it's pretty simple and straightforward. T1 by T2 will be r1 by r2. Let's use small r, r1 by r2. T1 is time period on Earth 4, T2 is time period in space station 6, and r1 is R1 is the clock is placed on the surface of the Earth, right? It's placed on Earth, so R1 will be center to the surface, which is the radius, right? So which is 6400. Okay, so R1 is nothing but radius. R2 will be the radius plus the height. Okay, here it's also mentioned in the question that height h above the Earth's surface. So height is always measured from the surface unless otherwise mentioned. Okay, so height is h from here, okay, from the surface of the Earth. Okay, so the distance small r over here is from the center. So here it will be r plus h, the radius of the Earth plus the height h. Okay, this r is from the center. Okay, this r is from the center, r from the center. Okay, so 6400, which is from the surface. Okay, and then we have the height h, right? So now we can find h. 6400 plus h will give us 6 by 4 into 6400. This is 1600. Okay, 16 6 16 5 is 80. If you add 16, 9600. So 9600, so h is 9600 minus 6400. 96 minus 64, 32 and 2 zeros. Okay, so 3200 kilometers, if everything is in kilometers. So yes, your correct choice over here should be 3200 kilometers, 3200 kilometers. Yeah, that's from this question. Over to the next question. Question number 5 and 6 over here. In question 5, we have a vessel which contains 14 grams of nitrogen gas, which is at 27 degrees Celsius. So you are supposed to tell the amount of heat that needs to be transferred to this gas in order to double its RMS speed. Okay, now the RMS speed, you might know, it's proportional to the square root of temperature, right? RMS speed is given as under root 3 RT by M, 3 R and M are constant. So your RMS speed is directly proportional to the square root of temperature. Okay, so if you want to make the RMS speed double, okay, so if you want to make the RMS speed double, the temperature should be made 4 times, right? So the square root of 4 will be 2, right? So the temperature should be made 4 times the original temperature. Okay, so that is not the question. You are supposed to tell what is the heat that is needed to be supplied. Okay, so basically the question now becomes, what is the heat that needs to be supplied in order to make the temperature 4 times the initial temperature. Okay, now it's properly framed, right? So now the heat, we can say, will go to increase the internal energy, right? So the internal energy is a function of temperature, so it is given as NCV delta T, right? Internal energy is given as NCV delta T. Okay, now N is number of moles, CV is the specific heat capacity at constant volume. It can be found out using the formula FR by 2, okay, in terms of degree of freedom. Okay, and delta T, as we know, should be the, if you see, the initial temperature is 27, not 27 plus 273. Okay, so it's 300. Okay, so whenever you place the temperature, place it in Kelvin. Here anyways we are going to use delta T, so that won't matter, but here in other questions see that you substitute T in terms of Kelvin. Okay, now you have to make this 4 times, so you want to make it 1200 Kelvin. So, okay, so this is the temperature change, so 1200 minus 300, which is 900 Kelvin. Okay, so that is the temperature change that you want. Now number of moles can be easily found using sample mass, which is 14 grams, divided by the molecular mass 28, right? For nitrogen, one molecule is 14, so N2 is 28. Okay, so this is half basically, so half moles we have. CV we can find from here. Degrees of freedom, if you see, this is diatomic, right? We'll ignore the vibrational one, so we'll only have the 3 XYZ degrees of freedom, and we'll have 2 rotational, so 5 degrees of freedom. R will keep at as it is, divide by 2, so 5 R by 2, so 5 R is 8.32 and by 2. Okay, and into delta T we know it is 900, right? The change in temperature is 900. Okay, so 900. So actually we can divide this. Let's see. So here we'll have 450, and what is the half of that? I think it is 225. 400 it's 200, and 50 is 25. Okay, so 225, and again 225 into 5. If you want to do into 5 is like divided by 2. So 1125, is it 1125 into 8.32. Okay, 1125 into 8.32, whatever that is. I think the answer, if we check, it is 9360. Okay, do fact check me in the comment section if this is correct or not. Okay, let's come to this one. Here we have a slab of dielectric constant K. Okay, it has the same cross section area, so basically same area as your plates of the capacitor. So and thickness is 3D by 4. So basically the question is saying we have a capacitor, the separation between the plates of the capacitor is D. You have a dielectric constant material, okay, dielectric constant K of a slab. Okay, so this we are going to place it between the plates of a capacitor. Okay, but it has only a width of 3D by 4. Okay, 3/4 of the width. Okay, 3D by 4. Okay, so it is going to look somewhat like this. So you are supposed to tell the equivalent capacitance in this case. That's pretty simple. If you see, first of all, you are supposed to find this width, okay, this and this. It's pretty simple. Actually, you can also solve it the other way around. You can say this is 3d by 4, this length, and this is the remaining d by 4. Okay, but here we'll solve it as it's given in the question. This way also you'll get the correct answer. Here we'll solve it the way it is supposed to be solved. Okay, so here inserted between, it said, so we'll keep it in between. So this distance will be d by 8 and d by 8, right, because the remaining distance was d by 4. So here we have to split it among the two, right, so d by 8 and d by 2. So d by 8 and d by 8, because we are making half of d by 4. Okay, so let me draw it a little big. Okay, so this is 3d by 4, 3/4 of the distance. Okay, so we have 1/4 left. So 1/4 and 1/4 we have to split among this. 1/4 left total. So here we'll have 1/8, and here also we'll have 1/8. 1/8, 1/8 is 1/4. Okay. So now equivalent capacitance will be given as actually 1 by C will be 1 by C1 plus 1 by C2 plus 1 by C3. Right. This is C1, C2, C3. Okay. You can split it up. Right. So C1, if you see C1, let's write it over here. C1 is A epsilon naught d by 8, right, d by 8, that we can take on top, and this will be also equal to if you see C3. Okay, so C1 and C3 same values, then only change is C2. C2 will be A epsilon by d. D is 3d by 4, so we can substitute that, and epsilon will redefine as k times of epsilon naught, right, so k times of A epsilon naught by 3d. So if you see C naught is given as initial capacitance, okay, without the dielectric, without any shenanigans, so it is A epsilon naught by d. Okay, the simple capacitor, so without dielectric, spacing between them is d, so A epsilon naught by d, right. So if you see C1, C3, so C1 is equal to C3, you can write it as 8 times A epsilon naught by d, right, 8 times A epsilon naught by d, so 8 times C naught, and C2 you can write it as 4 by 3, so 4 by 3, and A 4 by 3, and K also we have 4K by 3, we can say, into A epsilon naught by d, which is C naught. Okay, now let's solve this. Okay, so we have C1 as 1 upon 8 C naught. Again we have C2 is this 4K C naught, and in the numerator we have 3. Okay, so basically these are reciprocals. Okay, that's why it's in the denominator, 1 by 8 C naught. So this will become 1 by 8, 1 by 8 will become 1 by 4. Right, that's why I was saying you can treat it this way also. Okay, now let's solve this. This will become, you can actually take 4 C naught common, right, so 1 upon 4 C naught is common. So here will be left with 1 plus 3 by 4K, I guess, no, 3 by K. Okay, so this will give us 1 by 4 C naught K plus 3 upon K. Okay, so this is 1 upon C equivalent, keep that in mind. So C equivalent will be reciprocal of this, which will be 4K C naught, only option A. So 4K C naught upon 3 plus K, K plus 3. Okay, so option A is correct. Over to the next question. Question 7 and 8 over here. In question 7 we have a uniform electric field given by this. Okay, M and E respectively stand for the mass and the electronic charge on an electron. So here the length of the plate as shown is 1 meter. Okay, an electron enters symmetrically between the plates, and it initially has a velocity of 2 meters per second. Now after its journey it will be deflected, right, it will be attracted towards the positive plate due to force on it. Okay, so you can see that it will leave the plates at some angle theta with respect to the horizontal. First it enters along the x-axis, along the horizontal, but after some time, okay, after passing through the electric field, there is attraction to the positive charge. Okay, so it will come out at an angle with respect to the horizontal. You are supposed to find that angle. Okay, the initial velocity is 2 meters per second. Actually very simple, might seem very complicated. First of all, you are supposed to find acceleration in the y direction. Of course there is sorry, no acceleration in the x direction. You can see the field is in this direction, so in the y direction, okay, like this. Okay, so the acceleration will also be in the same direction, although so it's electron, so it's in the opposite direction, and it is given by E by m, right? So basically mass into acceleration is q into E, right? So that is how we get acceleration. Ma is equal to Ee, right? QE, here q is electron, right? So this is your acceleration. Here the value of E is also given, so we can substitute that 8m by E. Okay, we are not substituting the signs over here, since it's we know the direction, right? We are not worried about the direction, we are just worried about the angle. Okay, so here the acceleration that we get is 8 meters per second square. So it is in standard units, so our acceleration will be also in SI units. Okay, so 8 meters per second square. What can we do next? We can find the time spent over here. Okay, why will we find time? Because what we want, the objective is to find the angle, right? The angle can be given as, so we already know the velocity in the x direction. There is no acceleration in the x direction, right? So the velocity is going to remain the same. Okay, no acceleration in the x direction, velocity in the x direction will remain same. Okay, only acceleration is in the y direction. So our objective is to find this velocity in the y direction. So we know velocity in the x direction, velocity in the y direction. So we can take tan theta, right? Tan theta will be Vy by Vx, and that will give us our answer, theta. Okay, so you can see 10 everywhere, right? So that is the objective. So find the velocity in the y direction. Okay, so for that we'll first of all find time. Okay, the time taken in this journey. Time is distance upon speed. So in the x direction. Okay, this is in the x direction. There is no acceleration. So you can use the simple formula, time is equal to distance upon speed. If there was acceleration, you had to use s is equal to ut plus half at t square. Now we are applying this in the x direction. So the distance is 1, right? Distance is 1 meter in the x direction, 1 meter, and the s, what is time upon speed? Speed is 2 meters per second. Okay, so the time taken is half second. So the time taken for this thing to happen is half a second. Okay, this happens in half a second. So now, what do we have to find? We have to find Vy in the y direction. So it will be given as Uy plus Ay into t. Okay, so the velocity in the y direction, final velocity will be given as initial velocity in the x direction. So basically subscript y. Okay, acceleration into time. Time is independent of frame of reference, unless we go into relativity, of course. But yeah, for our discussion, time is not relative. Okay, so here the time in x will be the time in y. Okay, so here u in y direction 2, no, it's not 2. In the y direction, initial velocity is 0. Okay, this 2 is in the x direction, so this is 0. Acceleration, we know it to be 8, and the time is half. So the velocity in the y direction is 4 meters per second. So this is 4 meters per second. So now you can see the answer. So tan theta will be y upon x, right? Velocity in the y direction divided by x. So this will become half. No, it will become 2. So theta is tan inverse of 2. Okay, which is option B. Okay, hope the approach is simple. Let's come to this one. Here we have a uniform wire. It has a resistance of 80 ohms. It is cut into 4 pieces, 1, 2, 3, 3 line 4 pieces, equal pieces actually. So each of them will have now resistance of r by 4, right? Because the resistance is directly proportional to length. So if you make the length 1/4, the resistance will also become 1/4. Here the area is constant, right? If you cut, the area is not going to change. Okay, so resistance is directly proportional to length and length only, since area is not changing. Okay, so here the resistance of each piece will become r by 4, which is 20, right? 80 by 4 is 20. Now all these 4 pieces are connected in parallel. So r by 4, r by 4, r by 4 in parallel. Okay, so all these pieces are in parallel. So it's pretty simple. The equivalent will be in parallel. Basically, if you have r resistance, r, it's basically r by n. Okay, so r is 20 over here. Each piece is having resistance 20. Okay, so it's r by 4, right? So 80 by 4, 20. And how many resistors in parallel? Now this is the formula for a parallel. Okay, identical resistance in parallel. You can also use 1 by r1 plus 1 by r2. same result you'll get. Okay, so that divided by 4 is 5, right? 4 resistances in parallel. N is the number of resistance in parallel. So if you have identical resistances in parallel, you can use this formula, and the answer that you get is 5 ohms. 5 ohms. Okay, so equivalent will be 5 ohms. So your statement 1 is correct. Let's see if statement 2 is correct. Okay, statement 2, what do we have to say? We have to comment about the thermal heat developed in 3R resistor and 2R resistor will be in the ratio 3:2 or not. Okay, we have to check that. Okay, so 3R and 2R, they are connected in parallel. So let's clean this up a little bit. Okay, so here we have 3R. So you have to be very careful when you're doing this question, because initially they have mentioned 2R and 3R. So you might take the ratio the opposite way. Okay, and if you see answer, if you do it that way, will be correct. Okay, and this way it's wrong. So statement 2 here is incorrect. But if you do it the other way around, the resistance this by this, then you will get this answer 3:2. Otherwise the actual answer should be 2:3, and this statement should be wrong. I'll prove it. So here basically if you see, they are connected in parallel, which means voltage across this and this is the same. Right? That is what is meant by parallel connection. So if you see the power radiated or the heat developed in resistance 3R and through power, basically in general I can write it is inversely V square by R, right? Inversely proportional to the resistance, V square by R. V is same over here, so power is inversely proportional to R. So power in the 3 ohm resistor divided by the power in 2 ohm resistor, that ratio we are supposed to find, right? 3 ohm to 2 ohm, okay, not 2 ohm to 3 ohm. Okay, so that is the key point over here. So here 3 ohms and here 2 ohm. This ratio is 2:3, right? So it's inversely proportional to radius 3, 2. Okay, so 2:3, not 3:2, which you might have got if you had done it the other way around, which you were not supposed to, because you are supposed to find the ratio 3 and 2, right? Thermal energy developed in 3, that in 2. Okay, so statement 2 is incorrect. The ratio is 2:3, not 3:2. So statement 1 is correct, but 2 is incorrect. Okay, so option C is correct. Over to the next question. So question 9 and 10 over here. Just a quick note before we begin with this. Today's paper is a bit more challenging than the previous two that we did. So if you are finding it a little bit tough or challenging, just stick with me. Okay, let's get it done. Okay, it's going to be a bit lengthy, but let's get it done. Okay, so here in question 9 we have a triangular shaped wire which is carrying a current of 10 amperes. It is placed in a uniform magnetic field as shown. The field has a magnitude of 0.5 Tesla. Okay, you are supposed to tell what is the magnetic force on the segment CD. Okay, this is the segment CD. Okay, it's very straightforward actually. The force on the segment will be IL cross B. Okay, IL cross B, or which is ILB sine theta. Okay, so it's the angle between the length vector and the magnetic field. Okay, if you see, the length vector is along the length, right? It's actually along the direction of the current. So length vector is like this and the magnetic field is like this. Okay, so this angle, no, that's not the angle. How do you see the angle between two vectors? It's very elementary. You should know that whenever you want to see the angle between two vectors, look out for the first match their tails. Okay, you to measure the angle between two vectors, you bring their tails together and then measure the angle. Okay, so what you are supposed to do, actually you are supposed to slide this vector over here. Okay, so the thing will be like this. Okay, so magnetic field is along the horizontal and you just slide this vector over here. Okay, so this angle is what you are concerned with. If you see, this is an equilateral triangle, so all the angles will be 60, 60, 60, right? And this angle here will be 120, right? So this is 120, so this will be 60 again. Or you can see that if you slide this down over here, right? So in a way, okay, yeah, so this is 120, then this will be 60, right? That is what I said. So your angle between the length vector and the magnetic field is 60 degree. Okay, so I is 10 amperes, length we know that it is 5 centimeters, 5 into 10 to the power minus 2. B is magnetic field 0.5. Okay, fine. And sine of 60 is root 3 by 2. Okay, so what can we do? Actually, we can cancel this. 5 is a, so I can 5 is a 25, 25 is a 125, and we can write it as 10 to the power minus 3, and this will be root 3. So actually 10 to the power minus 2, and this way we can write root 3 is 1.732. I can say that it is like 17. So 17 to is a 17 into 12 actually. So 17 into 12 is 170 plus 34. So 170 plus 34 is 204. So something very close to 0.30 shifting. So that is, I think, something very close to this. Okay, so I think either this or this, but this is very close, right? So I think option C is correct. Okay, just fact check that, but I think, yeah, option C is correct. Let's go to question 10. Here we have magnetic field. First, at the center of a current carrying loop, it is B1, and at a distance root 3, axial distance this is. So at a distance root 3 times the radius of the ring, okay, on its axis, the magnetic field over there, okay, at the axial point, okay, at root 3 times the distance of the radius. So at that point the magnetic field is B2. You are supposed to tell the ratio B1 by B2. Okay, B1, it's pretty straightforward. Magnetic field at the center of the current carrying loop, mu 0 I by 2R. Okay, and B2, it's not that straightforward, but the magnetic field at axial point is given as mu 0 I R square upon 2 R square plus x square. Here x square is the axial distance, root 3 times the radius. Okay, that whole raised to 3 by 2. Okay, so now we are supposed to tell the ratio B1 by B2. So B1 by B2. So if you see mu 0 I and mu 0 I will get cancelled, but let's write it mu 0 I upon 2R into, this will become reciprocal, right, and this is mu 0 I R square, right. So 2 and 2 will get cancelled. I think mu 0 I will get cancelled. R will become R cube, so R square plus x square raised to 3 by 2 upon R cube. So now we can substitute x as, so here from this we have x as root 3 by R, root 3 times the radius of the given circular loop, right. So root 3 R, and if you square it, x square will be 3R square, right, 3R square. So 3R square plus R square, which is 4R square, and in the denominator we have R cube. This is raised to 3 by 2. 2 and 2 can get cancelled, I hope. Okay, wait, what we'll do, yeah, we can do actually, so 4R square, right. So we'll write, for 4 we'll write 3 by 2 separately, and here also we'll write 3 by 2 separately. Okay, and here we'll have R cube. This and this will get cancelled. So this is R cube. R cube will cancel with this. Okay, and this is 4 raised to 3 by 2. So 4 raised to 3 by 2, I think it's 8. So 4 is actually 2 to the power 2, and this is 3 by 2. So 2 will get cancelled, and 2 raised to 3 is 8, right. So 8 is to 1. So correct option is option C, 8 is to 1. That's all from this question. Over to the next question. So question 11 and 12 over here. In question 11 we have a transformer which is operating at 8 kilovolts. This is primary voltage, and secondary is 160 volts. So step down transformer, and it serves a load of this. Okay, so basically this is output power, right. You can make it out from unit. It is 8 kilowatt. Okay, so that is power, and it's on the load side. Load meaning the output resistor, right. So here this is output power, okay, and it is given that the transformer is ideal, okay, all of that shenanigans. It's purely resistive, and the power factor is 1. This implies that, okay, and you are supposed to find the load in the primary and secondary circuit. Okay, one important point is that it's ideal, right. So the input power is same as output power. Okay, so I can say V1 I1, this is the current in the voltage and current in primary, so equal to the product of V2 I2. Okay, and it is given that the power output is 80 kilowatt. Okay, so from here we'll find I1 and I2. We already know V1 and V2, so we'll find I1 and I2, and from that we can find R1 and R2, right. So V1 I1, so V1 I1 can equate it to 8 kilowatt, and here also V2 I2 we can equate it to 80 kilowatt. Okay, so now substitute. V1 is 8 kilowatt, so 8 kilowatt volt, sorry, V1 is voltage, I1 here, and we have 80 kilowatt. So kilo gets cancelled 10 times, so I1 is 10 amperes, and let's find I2. So I2 will be 80 10 to the power 3. So I'm substituting 10 to the power 3 because here we have in volts, right, not in kilovolts. So this and this will get cancelled. 8 by 16, 0.5, 0.5 and this, so 500 amperes. Okay. So now let us find R1 and R2. R1 can be found out using V1 by I1, right? So V1 is primary side voltage, which is 8 kilowatts, and current is 10. So I think it's 800, pretty evident. R2 will be V2 by I2. So V2 is, if you see, V2 is 160, right, and I2 is 500. So it's 16 by 50, I think it's 0.32, just multiply 2 and divide 2. So this is 100 by 32, that is 0.32. So option C is correct over here, 800 and 0.32. Let's come to this one. Here we have a biconvex lens, its power is given. Okay, then the refractive index of that lens is also given. You are supposed to tell what is the refractive index of the surrounding medium, and it's given that R1 and R2. First of all, R1 will be of this surface, right? R1 is, so the incident ray will be incident on this surface first. So R1 is for this surface, so the radius will be in this direction. So R1 is plus 20, okay, in this direction of incident ray. Now R2, if you see, is for this, the ray is incident on this surface second, right? So I hope I framed that right. And so that circle is over here, and R2 will be minus 40 centimeter. Okay, minus because it is opposite to the direction of incident ray. R1 is for the first surface. Okay, it's in the direction of incident ray. So plus 20, and R2, if you see this circle, right, ray will be incident on this surface second. Okay, first on this surface, then on that surface. Okay, so that is for R2. R2 is 40, and it's in the direction opposite to your incident ray, so minus 40. Okay, so now just use the lens maker formula, which is 1 upon f is mu of lens upon mu of medium minus 1 into 1 upon R1 minus 1 upon R2. Okay, usually in your NCERT you just find it this way. Okay, because here you consider the medium to be air. Actually it's mu L by mu m, the medium. Okay, 1 by f is nothing but power is 1.25, and meter inverse we might need to convert it, and that will be 10 to the power, meter is 10 to the power 2 centimeter, right? So inverse, so minus sign, so I think it is 10 to the power minus 2 in centimeters. Okay, is it correct? I hope so. So let's come over here. Mu L is 1.5 of the lens. Mu m we are supposed to find minus 1. 1 by R1 is 1 by 20. 1 by R2 is minus 40, right, over here. So minus becomes plus. So let's solve it further. We can say 1.25 into 10 to the power minus 2. Here this will remain same. Okay, and here we'll have multiply and divide 2, so 2 by 40, so this will become 3 by 40. Okay, now solve it further. You can solve it over here. So 1.25 is actually 5 by 4 into 10 to the power minus 2. Okay, and here we'll have 40 by 3, right? So 40 by 3, and here we'll have 1.5 by mu m minus 1. So this and this can get cancelled as 10. What will be left with? So 10, and this is 10 to the power minus 1, it will become, so this is 0.5 by 3. So 0.5 by 3, okay, will be equal to, so just get that 1 on this side, so plus 1 is equal to 1.5 by mu m, right? So this will be 3.5, divided by 3 is equal to 1.5 by mu m. So mu m will be, just take it to the other side, 1.5 into 3 divided by 3.5, 1.5 into 3, 15 3s is 45. So better we can cancel this, okay, can cancel this. This is 0.3, right, 5 3s are, and this is 5 7s are. So we'll have 0.9 divided by 0.7 or multiply it by 10 and divide by 10. So 7 by 10, 9 by 7, what did I say? Okay, so option B, 9 by 7 is the correct choice. So I hope that was pretty evident. Let's move to the next question. Now question 13 and 14. In question 13 we have two streams of photon which possess energies equal to 5 and 10 times the work function of a metal. They are incident on that particular metal surface successively, one after another. The ratio of the maximum velocities of the photoelectrons emitted in the two cases. Okay, so you want to find the ratio, okay, of the velocities. Okay, so in the first case, the kinetic energy, basically Einstein's photoelectric equation, you are supposed to use E minus phi, right? So here the energies are given as, in the first case it is 5 times the work function, okay, so here you will be left with 4 phi, okay, and K2 will be E minus psi again. Here the second beam has energy 10 times the work function, so minus the work function will give you 9 psi, okay. So K1 by K2 is 4 by 9, right? If you take the ratio K1 by K2, it's 4 by 9, and K is proportional to velocity square, so V1 by V2 the whole square is proportional to 4 by 9, okay, right, because K is half mv square, so K is proportional to V square. So this implies that V1 by V2 will be 2 by 3 or 2:3, option C, okay, that's correct. Let's go to question number 14. Here we have a radioactive sample that decays 7 to 8 times its initial quantity, okay. You are in 15 minutes you are supposed to tell the half-life of the sample, okay. It's a very straightforward. You are just supposed to use this formula, n upon n0 is half raised to 2 to the power, means half to the power n, okay, and you can also write this as T by T, okay. So basically that gives you the number of half-lives, okay. Here small n is the quantity left, okay, very important point, that small n is the quantity left, okay. So initial quantity is n0, okay, so n will be initial quantity minus the quantity that has decayed, okay. This amount has decayed. It's told in the question that 7 by 8 of the original amount, so 7 by 8 of the original amount, which is n naught, so 1 minus 7 by 8, which is n naught by 8, okay. So this quantity is remaining, so let's substitute it over here, n0 by 8, and here we will have n0, so half raised to, here the time small t is given as 15 minutes, and capital T, here capital T stands for half-life, which you are supposed to find, okay. So this will cancel, and if you see, this is nothing but 2 to the power 3, right. So here also this will be 15 by t, so 15 by t will be nothing but 2 to the power 15 by t will be 3, okay. So 15 will be 3t, and t will be 5 minutes, okay. Capital T is nothing but half-life. Or you could have directly seen that this you could have, instead of this you could have kept it as n, where n is the number of half-lives, okay. So the number of half-lives is 3, so 3 half-lives in 15 minutes, so 1 half-life is 5 minutes, okay. So option A, 5 minutes is correct. Over to the next question. Question 15 and 16 now. In question 15 we are given an amplifier with current gain beta as 100. This is in C configuration, so you are supposed to tell what is the output voltage of the amplifier, okay. So let's see what is the data given. Here we have the input voltage, this is the input side, that is the output side. So input voltage we have, input resistance we also have the current gain, we also have the output resistance, okay. We are supposed to find output voltage, okay. So it's actually very simple, because voltage gain is nothing but current gain into output resistance by input, right. Or if you don't remember it this way, you can remember that it's the ratio. Voltage gain is basically output voltage by input voltage. Current gain is output current by input current, right? And this is output resistance by input resistance, right? So V is equal to IR, V is equal to IR, output output, input input. Okay, you can remember it that way. So voltage gain is VO by VI, right? Current gain, we are told that it is 100 beta. So output resistance is 10 kilo ohms, input resistance is 1 kilo ohms. So kilo ohms will get cancelled, and input voltage we can substitute it directly over here. It is 10 to the power minus 3, right? So this will give us 1 volt. Yep. So option B, 1 volt. Let me check that. So yes, 1 volt is the correct choice over here. Okay, output voltage is 1 volt. Okay, let's come to this one. Here we have an FM broadcast. Actually, this question is very similar to what we did in one of the previous papers. Okay, here you are given the frequency of the modulating wave. You are supposed to tell the bandwidth. Bandwidth is basically given as, so bandwidth, I can say delta omega is 2 times the frequency of the modulating wave. But here there is a slight tadka or twist. Okay, so here we are given the deviation ratio. So deviation ratio is basically we can say relative error. Okay, so delta F by F will be 100. Okay, sorry, 10, deviation ratio of 10, right? So here F is 20 kilohertz. Okay, so here FM you have to put it with the error. Okay, so here FM will be F plus delta F. Okay, so basically you have to put the term with its error. Okay, so here delta F you have to substitute. So F is nothing but 20 kilohertz. So 20 into 10 to the power 3. Fine. So what will be this? This will be, I guess, we'll keep kilohertz as it is. So since the answers are also in kilohertz, so this is 200 kilohertz. Okay. Now omega will be given as delta omega is 2 times of FM. FM is itself F plus delta F. Okay. So the frequency plus the error in it, I can say. So frequency is 20 and error is 200. So this is 220. 220 into 2 is 440 kilohertz. Right. So option D, 440 kilohertz, is the correct choice over here. It was pretty similar to the last question. So the questions on communication are pretty similar, and this question is pretty much repeating in the papers. Okay, these papers are based on JEE papers. I hope you know that. And yeah, that's from this question. Let's move to the next set of questions. Let's come to question 17 and 18 over here. In question 17, we have a pressure pump which has a cross-sectional area of 10 centimeters square. Okay, the outflow of water from this pump is at the rate of 20 meters per second. You are supposed to tell what will be the force exerted on the wall. Okay, so this water is flowing out horizontally. So there is a wall, vertical wall in front of this pump. So what is the force which is exerted on this wall which makes the water to stop? Okay, so initially water is flowing with 20 meters per second in the horizontal direction. Finally, when it collides with the wall, it comes to rest. Okay, so what is the force exerted on the wall? Okay, pretty simple, straightforward. You are just supposed to use Newton's second law, which says that force is ma. No, force is rate of change of momentum, delta p by delta t. Okay, this process is happening continuously. So we'll consider it for 1 second. Okay, so in 1 second some fraction of water will be stopped by the wall. So we'll consider this drama happening for 1 second. Okay, so a change in momentum in that 1 second is m delta v. Okay, so if you see the mass of water can be found out using density into volume, right? So density is given 10 to the power 3. Volume you can write as area into the fraction of water. Now for 1 second, what will be the amount of water which is flowing out? It will be 20 meters, right? The water is flowing 20 meters in 1 second. So 20 meter amount of water will come out in 1 second. So using that logic, this height or this h, okay, is the fraction, the amount of water that is coming out will be of the length 20 meters. Okay, it is traveling 20 meters in 1 second, right? So this h will be 20 meters. Area is 10 to the power, okay, it's 10 centimeters square. So 10 into 10 to the power minus 4. right, centimeter square. So convert that into meters, and this is height, so that is 20 meters for 1 second we are considering. So this will be 10 to the power 4, so this will be nothing but 20, right? This and this will get cancelled, only 20 will survive. So let's substitute it over here, 20, and here also what is the change in velocity. Mass is 20 kgs, okay, everything is in SI, so mass is 20 kgs. And what will be the change in velocity? So the change in velocity is from 20 to 0, right? The water stops flowing out, so I mean it stops after hitting the wall, so the change in velocity is 20 to 0, so basically it is 20. Okay, so the answer is the force on the wall is 400 newtons, option D. Okay, let's come to this one. Here we have a cylinder. Let us draw it side by side so we can imagine it. So cylinder of radius 1 meter, so this has a radius of 1 meter. Okay, so diameter will be 2 meters, and we also have a piston which will come into the picture later. So the top surface is at a distance of 15 meters from the bottom. Fancy way of saying that the height is that the depth of this cylinder is 15 meters. Okay, so now there is a hole at the wall, one of the wall of the cylinder, and it is at a distance of 5 meters from the bottom. Okay, 5 meters from the bottom, so 10 meters from top. So this distance is 10 meters. So this orifice or the hole is at 10 meters from the top, okay, and 5 meters from the bottom. Okay, a force of 5 newtons. So this using this piston we are going to apply a force F of 5 into 10 to the power 5 newtons, okay, on top of the water with the help of piston. So the speed of efflux from this orifice, okay, you are supposed to tell with what velocity will be the water ejected out, thrown out of this orifice. Okay, you are given the relevant data over here. It's actually straightforward application of your Bernoulli's principle. Okay, you are supposed to mark this 2 point, one which is inside and one which is outside, and use Bernoulli's principle. Okay, so here we'll use a Bernoulli's principle. So P1 rho G H1 plus half rho V1 square equal to, so this is for this point 1 and this is for point 2. Okay, P2 rho G H2 plus half rho V2 square. Okay, so if you see here, inside the water is still, right, the water is not moving, so the velocity is 0. So inside at point 1 the velocity will be 0, hence this term will be 0. Pressure at point 1 is basically force. Pressure is force per unit area, right? Force is given and per unit area, so 5 into 10 to the power 5 per unit area pi r square, right? So basically the cylinder, it's a cylinder, right? So the surface, okay, so force is on this cross sectional surface, it is a circle, right? So pi r square, so pi into 1 square doesn't really matter if we write it or not. Sorry, let's come to this one. Rho G H1, rho is 10 to the power 3, G is 10, H is, H if you see, it's the height of the liquid column, right? So if we are finding pressure over here, it's the height of the liquid column which is above it, right? So the pressure on this point is due to the liquid column on top of it, right? So that liquid column has a height of 10. Okay, so this is the left hand side. Let's see for the right hand side. P2, the point 2, if you see, it's outside, right? It's outside the outside in the atmosphere, right? There is no liquid column on top of it. Okay, so it's completely outside in nature. So the P2 is nothing but the atmospheric pressure, which is given as 1.01 into 10 to the power 5. Okay, now the next thing, if you see rho G H2, now here there is no liquid column on top of it, so this will become 0, and here half rho is 10 to the power 3 again for the liquid, and V2 is the velocity with which it is ejected, right, which we want to find out. So V2 square, which we want to find out. Okay, so let me just clean this up so that we can solve that. Okay, so now what do we have? We have 5 into 10 to the power 5. We can simplify this further. Actually we'll multiply 2 everywhere, so we will have 2. So multiply each term with 2, So this will become 10 to the power 6 by pi, right? 5 2s are 10, and that you mix up with the other ones. So here if you multiply 2, so we'll keep it separate, 2 into this will be 10 to the power 5, and here you'll have 2.02, so 2.02 into 10 to the power 5, right? And finally we'll have 10 to the power 3 v square, okay, v2 square. We are supposed to find v2. So now again let us divide everything by 10 to the power 3. Okay, so this will become 10 to the power 3 by pi. This will become 10 to the power 2, right? So you can multiply that, so that will become 200. Here we'll have again 10 to the power 2, so this will be 202, okay, plus v2 square, okay. Now let us solve this. This is 1000 by pi, and this will be 200 minus 202 minus 2, right? So this is v2 square. So if you solve this, so if you see it is like 1000 divided by 3, right? So it's 333 something. So roughly, okay, so roughly I'm saying it's 333.33 something, okay, minus 1, so 331, okay, 331.33. Okay, actually it will be lesser than this, okay. So the value is approximately this, or actual value. If you calculate it exactly, it will be less than this. This is v square, okay. So which value has the closest square to this? If you see 17 square is 289, 18 square is 324, okay. So I will give you a pro tip that you should remember the squares up till at least up till 20, okay, by heart. So 3 to 4. So if you see this is something between 17 and 18, right? And it is very much closer to 18, 331, and I told you this is not exact value will be a little less, since we used approximated pi as 3, okay, it will be 3.14, so this value will be effectively lesser, okay. So it will be very close to something 18, okay, very close to 18. So if you see, it is option C, okay. So option C, 17.8, which is very much closer to 18, is the correct choice over here, okay. So let's move to the next set of questions. So question 19 and 20 over here, the last two questions before we move to the numerical types. So let's do this. So here in question 19, we are supposed to find the average speed of a body which travels 1/3 of its initial 1/3 of the total distance with speed v, second 1/3 with speed 2v, and the remaining distance, the last 1/3 with speed 3v. Okay, so let us consider this journey. We'll consider the total distance to be 3d. Okay, you can also take it as d. I'm taking 3d so that we can divide it by into 3 parts, right? So we can divide it into 3 parts as d, d and d. Okay, you can also take d and divide by d by 3, d by 3 and d by 3. So this distance it will travel with velocity v, speed v, here 2v and here 3v. Okay, so average speed is basically the total distance, right, total distance upon the total time taken, right, total time taken. Okay, so total distance, if you see, of the journey is 3d, right, the body travels the distance 3d. Okay, what about the time? Actually for time we have to split it in 3 different journeys, okay, for this 1/3, this 1/3 and this 1/3. Okay, so t1, the time in this journey will be distance upon speed, right, uniform acceleration, sorry, uniform motion, so no acceleration, so you can use time is equal to distance upon speed. T2 similarly will be distance upon speed 2v. T3 similarly will be d upon 3v. Now let us solve it. So the total time is basically the sum of this, so d by v, d by 2v and d by 3v. Okay, d will get cancelled, and in the numerator we have 3. Let us take the LCM. So let us solve the denominator, take the LCM. So 1 by v we can take common, so 1 plus half plus 1/3. 1 plus half, 3 by 2, 3 by 2, and actually we can say it is 1 plus half plus 1/3, right? So the LCM will be 1 by 6. So this will be also 6. This will become 3 2s are 6 and 2 3s are 6, right? So now take 6v in the numerator, so it will be 6 3s are 18v. Okay, so simply I'm solving. 6 plus 3 is 9, 9 plus 2 is 11, right? So 18v by 11, which is option C. So option C is correct over here. Okay, let's come to this one. This one is also straightforward. So in electromagnetic wave, you are given the maximum value of the electric field E naught to be 120 Newton per coulomb, you are supposed to determine B naught. Pretty straightforward. The formula is E naught is equal to E naught by B naught is C naught, right? E naught by B naught is C. C is the speed of light, right? So B naught will be E naught by C. E naught by C. So E naught is, if you see, E naught is 120 and C is 3 into 10 to the power 8, right? So this is 40 and 10 to the power minus 8. Over here we have everything in terms of minus 9. So 400 into 10 to the power minus 9. Okay. So which is option C, right? Again, option C, yes. So that's all from the MCQs. Let's do the slightly challenging numerical type questions now. Stepping into the territory of our integer based questions. So question 21, we have a string of area of cross section 4 millimeter square. The length is 0.5 millimeter, is connected with a rigid body of mass 2 kgs. Now you are going to spin that or rotate that in a vertical circle, okay, and of radius 0.5 meters, the length of the string. Basically the body acquires a speed of 5 meters at the bottom of the circle. So you are supposed to tell what is the strain produced in this string, okay, what is the change in the dimension, the ratio of change in dimension to original dimension, that is strain, produced in the string when the body is at the bottom of the circle. Okay, pretty simple, because at the bottom of the circle basically the mass, okay, the force will be outward, mg, first of all acting in the downward direction, right? So at the bottom of the circle, okay, mg in the downward direction, and also the tension, okay, or the centripetal force will be mv square by r, okay, we shall say centrifugal. Let's go into the frame of that block. Okay, so centrifugal force mv square by r, also in the downward direction, okay, and this should be balanced by the tension. Okay, so T should balance mg and mv square by r. Okay, so if you see m we can take common, g is 10. Now let us directly do it. M common and it is 2 in value. G is 10. V square, if you see velocity is 5, right, at the bottom. So 5, 5, 25, and that divided by r. R is 0.5. Okay, r is 0.5, right, the radius or the length. So here we'll have this as 5 times, right? This is 50 times actually. If you divide it by 5, it will be 5 and 0.1, right? 0.1 in the denominator basically makes it 10 in the numerator. So 50 plus 1, 60 into 2, which is 120 newtons. Okay, this is exactly what you are not supposed to find. Okay, but yeah, this will help us in finding the strain. Okay, I mean strain, but the S is silent. No. So let's come to the strain. Strain is basically you are given the Young's modulus. So from there you can find stress by strain, right? Young's modulus is the ratio of stress by strain, right? So from here you can find strain. This is nothing but the force, right? Here stress is force by area, right? So that's why area is given. Okay, so strain will be your Young's modulus. Stress by Young's modulus, right? So stress is force per unit area. This is the force, right? Force produced in the string, the tension, right? That force is 120, and per unit area, so per unit area is 4 millimeter square. 4 into 10 to the power minus 6 in meters, right? 1 millimeter is 10 to the power minus 3, so that squared is 10 to the power minus 6, right? And that into Young's modulus, right? Strain is stress by Young's modulus. Stress is force per unit area, and Young's modulus 10 to the power 11. Okay, this is 4 3s. Okay, and if you see, this is 10 to the power 5, right? So 30 into 10 to the power, this will be positive 5. If you take it in the numerator, it will be minus 5. So 30 into 10 to the power minus 5. Okay, so yes, you want it in terms of minus 10 to the power minus 5. So here answer will be 30. Okay, 30 into 10 to the power minus 5. Let's come to this one. Here we have a gas at certain temperature. Its degree of freedom at that particular temperature is 8 for per molecule. Okay, the gas performs a work of 150, okay, when it expands under constant pressure, so the work is P delta V, right, when it expands under constant pressure, right. So the amount of heat absorbed by the gas. So here basically you are supposed to use the thermodynamics law, U Q is equal to U plus W. Okay, the heat absorbed or the heat released is the internal energy plus the work done, right. The heat provided will be utilized by the internal energy and in doing some work, okay, to frame it properly. Okay, so now we are supposed to find this heat which is absorbed by the gas. So the first of all, the work done is 150, we already know it, so work done, no issues over there. But what about internal energy? Okay, so internal energy, we have used this formula previously, it is NCV delta T, right, NCV dt we can say, okay. But the problem over here is we don't know anything about this dt, right. So CV also you can write it as FR by 2, right. Previously also we did the same thing. So the problem is we don't know anything about the temperature change that is happening over here, okay. But we know that the gas is performing the work under constant pressure, right. So under constant pressure the work is PdV, right, or pressure into delta V microscopically, okay. So PdV, okay. So you can write the ideal gas equation as PV is equal to nRT. Now if you differentiate on both the side, P is constant under constant pressure, so nR is also constant, number of moles, R is a universal gas constant, okay. And if you differentiate you will get P dV is nR delta T, okay. So here you have, if you see here you have nR delta T, so nR delta T, in place of that you can put P dV, so nR delta T you can replace it by P dV, so F by 2 will remain as it is, okay. And P dV is nothing but, this is nothing but work done, right, and which is 150, right. So P dV is nothing but work done, which is 150. F is degrees of freedom, which is 8, 8 by 2 4, 150 by 4, 150 is 300 by 2, 300 by 2, so what am I doing, okay. So that is 600 I guess, right, is it. So 150, you see 450 times 4 is 200, yeah, it's a complicated way of doing it. So 600 plus, so internal energy is 600 and 150, that is 750, so 750 joules is the answer over here. Over to the next question. Coming to question 23 and 24 over here. In question 23 we are given the potential energy of a particle which is moving along the x-axis, okay. It is given as this, okay. It is 4 cos 1 minus cos 4x, that is in joules, and the time period for small oscillations performed by this particle where sin theta is approximately equal to theta is pi by k. So the small oscillations that we are mentioning over here is nothing but SHM, okay. That's the only small oscillation in your course, okay. So you are supposed to find the value of this k, okay. So first of all, the time period in any SHM is given as 2 pi under root m by k, okay. Don't confuse this k with this k, okay. This is some constant k, okay, and this k is the constant of restoring force, right. It's due to the restoring force F. Here in SHM, in any type of SHM, you can express force as minus kx, right. So k, this k is the restoring force constant, okay. Now first of all we have to find this k, we'll substitute it over here and we'll express our time period, and that time period will compare with this, and that will give us the value of this k, okay, which we are supposed to find. So first of all the question is how to get to force, okay. We are given the potential energy and the answer is simple. Force is nothing but gradient of potential energy, or the derivative we can say, okay, at your level. So del u by del x, okay, and this will be along I cap, but let's only consider the magnitude, okay. So minus 4, okay, so I'm taking the derivative of this, 4 is constant, I'm taking it out, del by del x of 1 minus cos 4x, okay. So it will be minus 4, and here 1 is constant, so here derivative of cos x is minus sin x, and this sign will cancel, okay. So sin 4x, again 4x we have, so we have to multiply, use the chain rule, so derivative of 4x is 4, right. So here we get minus 16 sine 4x. Now we are told that sine of theta is basically equal to theta. We can approximate that for this question. So in place of sine 4x, you can simply put 4x. Okay, so that will make it 64x, right? So 4x into 16, that will be 64x. Okay, so you have expressed the force. This is force, right? Force in terms of minus kx. Okay, so this k you can substitute in the time period. Let us do it over here. Time period is 2 pi under root m by k, as I told you, right? So here, okay, let us solve it. So 2 pi m is mass of the body is given as 4 kg, and the constant k over here is 64, right? You compare it with this, you can see that the constant is 64, and the time period, we are told that the time period of this oscillation is pi by k, capital K, where we are supposed to find the value of this k. Okay, so pi and pi will get cancelled, so we have 1 by k, here we'll have 2, and this is, if you see, 4 16s are 64. Okay, so 1 by 16, so that under the square root, so we'll have 4, so this will give us 2, so k is nothing but 2. Okay, the value of k over here is nothing but 2. Let's come to this one. Here we have a inductor. Okay, actually we have a circuit, in that we have an inductor. We are supposed to tell the current through the battery, 6 volt battery, when the circuit is just closed. Okay, when the switch S is just closed at t is equal to 0, you can say. Okay, so here the key point, as I said, there is a inductor in the circuit. Okay, so I gave a huge spoiler over there. Okay, so anyways, so here what does the inductor do? The inductor basically opposes the current, right? Opposes the state of current, I shall say. Okay, so if the current is growing, the inductor will oppose it. It will produce a magnetic field, and it will produce a current which opposes the existing current. Okay, so if the current is growing, the inductor will oppose its growing. Okay, it will okay, so it basically opposes the change. Okay, and if the current is decaying, it will support it. Okay, so here in this case, when we just close the switch, the current is trying to grow in the circuit, right? Initially when the circuit is open, current is 0, right? So when we just close the switch, the current is trying to grow. Okay, so at t is equal to 0, there will be opposition to the current, right? The current is trying to grow and the inductor will try to oppose it. Okay, so at t is equal to 0, the opposition will be maximum and the inductor will not allow any current to pass through it. You can also say it by the equation of current growth. The current growth in an inductor is given as I is equal to I naught 1 minus e to the power minus t by tau, right? I hope it is correct. So at t is equal to 0, what happens? At t is equal to 0, this term is 1, right? E to the power 0, anything to the power 0 is 1. So this 1 and 1 minus 1, that is 0. So the current through the inductor, okay, will be 0. Okay, so current will be opposed at t is equal to 0. The inductor will not allow any current to pass through it. Okay, so basically the inductor will break this branch. Okay, at t is equal to 0. Okay, the opposition will be maximum. Okay, so this branch will be open. The current will flow only in this loop when you close the circuit at t is equal to 0. Okay, so here I will be V by R effective, right? So V is 6 volt battery, and resistance, if you see, this branch is open, current is flowing in only these two resistors, and they are in parallel. No, they are in series. Okay, because same current is flowing, right? I is flowing, I is flowing. No current goes out from here, it's broken. Okay, so same current is flowing in both, so they are in series. Okay, mind you. So 4 plus 2, that is 6, and the answer is 1 amperes. Okay, so 1 amperes is the current flowing in our circuit. Okay, and there is a quote that I usually say, that inductor basically hope is what inductor is to a dying current. Like, just like the inductor supports the dying current, okay, it will not let it die. Hope is what you should have in your life, okay, in order to support it. Anyways, let's enough of life lesson, let's come to the questions. So over to the next question. So question 26 and 27 over here. In question 26, we have an object which is placed in front of a concave mirror. It is at a distance of 100 centimeter. The radius of curvature of this concave mirror is 200 centimeters. The object starts moving. So initially it was at rest. Now it moves with a velocity of 2 centimeters per second towards the mirror. Okay. So you are supposed to tell what will be the position of the image after 10 seconds once the motion of this begins. Okay. So after 10 seconds this object will have traveled some distance, and you are supposed to find where will be the corresponding image of that object. Okay. So basically initially it is at a distance of 100 centimeter. We are told that, right? It is at 100 centimeter. So after 10 seconds, what will be the distance traveled by this? So distance will be speed into time, right? So speed is 2 centimeters per second and into 10 seconds. So the distance will be 20 centimeters. So it will have traveled 20 centimeters. Okay. So what will be the object distance now? So after 10 seconds, the object distance will reduce to 80 centimeters, right? Because it has traveled 20 centimeters towards the mirror. Okay. So now the object distance, the new object distance is minus 80 centimeters, right? So minus because it is in this direction, right? Opposite to the direction of incident ray. Now the focus of this mirror, if you see radius of curvature is given, it is 200. So focus is r by 2, right? So that will be 100, and with a minus sign because this is a concave mirror, again the focus lies on this side, right? Opposite to the incident direction. Now you can use mirror formula and clearly find where is the image at when the object is at this distance after 10 seconds, right? So where is the image at 10 seconds? Okay, so you can use the mirror formula, or the smarty pens can directly use the formula v is equal to u f upon u minus f. Okay, this is something which is obtained from the mirror formula itself. It is the relation in terms of v. Okay, you can remember small things like this. So u into f, so 80 into 100, minus sign will get cancelled, minus plus. Okay, and then we have u minus f. So minus 80 minus of minus 100. So minus 80 plus 100, which is 20, right? Minus 80 plus 100, which is 20. So 20 4s are 80, and this will be nothing but 400. Okay, so the distance from the mirror is 400, and it is positive, which means that it will be a virtual image on the other side of the mirror, right? So you can verify that. Actually, if you see, O is nothing but the focal point. If you see the focus, the radius of curvature is 200, focus is at 100 centimeters. So initially your object was at the focus, so F is the focus point. So now after 10 seconds, your object is between F and P, between the focus point and the pole of the mirror, and in this case the image is virtual, right? It's on the other side of the mirror. You can verify that, and yeah, the answer is correct. It is 400 centimeters. Okay, now let's come to this one. Here we have a rod, one dimensional rod. Its mass density is given as this. It has a length L. Okay, and the position of the center of mass, okay, position of its center of mass from one end, from the end A, is given as 3L by alpha. Okay, you are supposed to tell the value of alpha. Okay, so let us imagine this. Okay, so we have rod AB. Okay, now at a distance x, okay, we are going to do this by the process of integration, because RCOM, the position of the center of mass for a mass distribution, is given as integration R dm upon integration dm. Okay, so now R is the distance over here, x. Now we can write dm for this. Actually we can express the linear mass density as dm by dx. Actually it is m by L, which is also equal to dm by dx. For this small element we have dm by dx, right? So you can write dm as rho dx, right? Because everything we want it in terms of x so that it is easier to integrate. So dm is rho dx. So let's substitute it now. The integration will be from 0 to L, from 0 to the entire length of the rod over the entire distribution. Okay, I have written the answer now because actually I recorded it and the voice was not recorded. So yeah, anyways, let's do it now. So R is, if you see, R is nothing but x over here, dm is rho dx. So rho, you can substitute this, rho naught 1 minus x square by L square and dx, right? So in the denominator also you'll have dm, which is rho dx. So rho is rho naught 1 minus x square by L square into dx. Okay, So now let us solve it. So here if you integrate, so first of all you can cancel out rho is constant and it will come out of the integration sign, so you can cancel it out and now integrate. So here you'll have x and x cube to integrate, right? So x integration of that is x square by 2 and integration of x cube will be x to the power 4 by 4 and in the denominator we have L square. So this is 0 to L, okay, and now integrate this. Here we will get x and x cube by 3 and also we have L square, okay. So again 0 to L, okay. So now let us solve it. We have x square, so substitute only the upper limit, lower limit is 0, so again that gives 0. So here we will have L square by 2 minus again L to the power 4 and okay, let us do that, L square by 2 and here we have L to the power 4 upon 2 upon 4 L square, right? And in the denominator we have L minus L cube by 3 L square, okay. So if you see L cube and this will get cancelled, only L will be left, right? So here if you see L to the power 4 will become L square, so L square by 2 minus L square by 4, so 1 minus 1/4 is 1/4, so we'll have L square by 4, okay. And this if you see in the denominator L minus L by 3, right? L minus L by 3, 1 minus 1/3, 2/3 and write it the other way around, so because that is in the denominator, so 2L by 3, okay. So L and L will get cancelled, we'll get 3L by 4 2s are 8, right? 3L by 4 2s are 8. So if you compare that with 3L by alpha, the value of alpha is nothing but 8, okay. So that's from this question. Over to the next question. So question 27 and 28 over here, few questions left before we end this paper, so let's pull up our socks and do it. So here in 27 we have an experiment being conducted to find the acceleration due to gravity through simple pendulum. So the time period of the pendulum is measured as 0.5 through 100 oscillations. The watch that we are using has a resolution of 1 second, so it can only take 1 second at a time, no seconds in between. Least it can measure is 1 second. And if the measured value of the length of the pendulum is 10 centimeters and it's known to our accuracy or the error in the measurement is 1 millimeter, you are supposed to tell the accuracy in G is, okay. It's found to be x, so the value of x, okay. So here a time period is 2 pi under root L by G, right? So square it on both the sides, it will be 4 pi square L by G. So G can be written as 4 pi square L by T square, right? So the error in G, delta G by G, let us take it as percentage error into 100%, will be the error in L, relative error, plus T is to the power 2. Here 4 pi square is constant, so no issues over there, so no errors in the constant. The error in T will be 2 times delta T by T, okay, because it is to the power T, so it is to the power 2, so 2 times delta T by T and that into 100%, okay. So now let us solve this. Delta L by L, the length, the error in length is 1 millimeter, so 0.1 centimeter, we can write it that way, divided by 10. 10 is the length of your pendulum. 2 times delta T. Delta T, if you see, it is 1 second, right? No, it's not 1 second. It is 1 second for 100 oscillations, okay. So for one oscillation, it will be 1 by 100, okay. So the more you repeat the experiment, the higher number of oscillations you take, the better the experiment will be, okay. So for 100 oscillations, this is the total error, okay. 1 second is the total error, so in one oscillation the error is 1 by 100. This 0.5 is time period for one oscillation, right? That is the meaning of time period, right? So it's for one oscillation, right? So in one oscillation this will be the error, okay, 1 by 100, okay. So 1 by 100, delta T is 1 by 100 and T is 0.5, right? 0.5 in the denominator, you can write it as 2 in the numerator, okay. So that is in 100%. So if you see, this is nothing but 0.01, right? 1 divided by 10, this is 0.01, so 1%, and 2 into 2 which is 4 divided by 100, so again 4%, so this is 4%, this is 1%, so total error is 5%, okay. So that's our answer. Let me check if the camera is still recording. Sometimes stops recording. Okay, I don't know what the hell is wrong with it. So let's come to question number 28. So here we have a string which is over a massless pulley. Okay, the arrangement is as shown. L length is hanging on this side, L minus L. So capital L is the total length, so L minus L is hanging on the other side. Okay, you are supposed to tell at a certain point the acceleration of the string is going to become g by 2. Okay, at that time, at that point of time, the length on this side is L by x. Okay, you are supposed to tell the value of x. Okay, now the acceleration in a pulley problem is given as the net force. We can say it's m2g minus m1g upon the total mass, m2 plus m1. Here the total mass is basically the mass of the string, right? So m2 so here the force will be more, right? More part of the string is on that side, so there the force will be more, here it will be less, so m2g minus m1g. Okay, so actually you can derive this using by framing the equations for equation of motion for this side and that side, but this is a general result, right? A net is net force m2g minus m1g upon the total mass. So m2g is downward and m1g is downward. Okay, so it's on the opposite side, so m2g minus m1g. Okay, and the total mass. So that will give you acceleration. So if you see m2g will be nothing but, so if you see the rod is uniform, so you can say mass density, so which is m by L times the length, right? So mass of a particular section of the rope is given as mass density times the length. So mass density times the length. So m2g is m by L into length, which is L minus L. Okay, so m1 similarly will be mass by length, the linear mass density times the length. Okay, so here the length is L and the total mass of the rope is m. So m can get cancelled. So here you will be left with L minus L, and g is also there, don't forget that. We want to find the length when the acceleration becomes g by 2, so we'll substitute that as well. So here we will have L minus L by L and small l by capital L, and that into g. G and g can get cancelled. So here we will have half is equal to this will be L minus 2L divided by L, right? So let's solve it further. Actually it's pretty evident from there that L will be 1/4 of the capital L. Okay, so here you can cross it over, so L will be given as 2L minus 4L. Okay, just take this to the other side and this to that side. So here we can find small l, 4L will be equal to L, right? Just shift it, and L will be L by 4. So you can see that when the acceleration is g by 2, the length is L by 4. So the value of x over here, if you compare, it's 4. Okay, so that's from this question. Let's move to the last two questions for the day. So question 29 and 30 over here. Question 30 is your homework question. You will do it and let me know the answers in the comment section of this video. So let's come to question number 29. Here we have, long story short, we have some water in a tank. The water level is 18 centimeters from the bottom of the tank. On the top of water we have a oil droplet which forms a convex lens, actually a plano-convex lens of a radius 6 centimeters. And on top of that it's air. Okay, and an object is placed in air which is at a distance of 24 centimeters from the oil water interface. I know the scaling is not correct, but you get the point. Okay, this is 24 centimeters from this. Okay, so you are supposed to tell what is the final image. So location of the image is at a distance x from the bottom of the tank. Okay, so you are supposed to tell what is the value of this x. Okay, so you are just supposed to use the refraction formula twice. Okay, mu2, which is mu2 by v minus mu1 by u is equal to mu2 minus mu1 upon r. Okay, first we'll use it for air oil interface. Okay, and we'll get an image. That image will act as a virtual object for oil water interface. That is the concept. Okay, so mu2 is the second medium. The second medium over here is oil, so 7 by 4, so 7 by 4 v we can say here. Mu1 is the air, medium is air, and u is the object distance. If you see, it is 24 centimeters and it is opposite to the direction of incident ray. Incident ray is like this, right? And this distance, object distance is negative, so minus 24, so that will make this plus. Okay, so again mu2 minus mu1, 7 by 4 minus 1, and r is the radius of curvature, okay, of this lens. So if you see, it is in the positive direction, right? It is here, okay, the radius is here, okay. So this is the center, this is the radius, so it is along the direction of incident ray, so plus 6, okay. So 7 by 4v plus 1 by 24, here we'll have what is this, 7 by 4 minus 1, so 3 by 4, so 3 by 4 into 6, so this will become 2, so 7 by 4v, 4 2s are 8, 1 minus 1 by 8 minus 1 by 24, so this will become, if you see 1 by 8 is common, 1 minus 1/3 is 2/3, right? So I think this should be like this, right? So I think yeah, this will cancel this as 4 will get cancelled with 4, so V is 7 3s are 21 centimeters, okay. So V is plus 21 centimeters, okay, and the distance is measured from here, right? All of the distances are measured from the center of the interface, right? So this is actually a very small lens, okay? So all distances are measured from here. Although you are supposed to measure it from here, it will be from here, okay. It's a very thin lens, right? We have discussions on thin lens. So here the distance is 21 centimeters, okay. So somewhere maybe over here, okay. So the image due to the air oil interface is at 21 centimeters, okay. Now this is not the final image, this will act as a virtual object for oil water interface, right? So for oil water interface, we are again supposed to use the formula mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. Water, and so mu2 is 4 by 3 V and mu1 will be oil. Oil is if you see 7 by 4, and the distance, if you see, the distance is plus 21, right? Plus 21. So this object, this image actually, due to the air water interface, will act as an object for the oil water interface, okay. So if you see the right hand side, we have by R, right? By R means if you see, the radius of this surface is infinity, right? This is a normal surface, this is a flat surface, so radius of curvature of that surface is infinity, so the right hand side will effectively become 0. So here we'll have 4 by 3 V is equal to 7 by 4 into 21. So can we cancel out something? I think we can. 3 7s are 21, 7 cancels with 7, right? 7 3s are 21, that will cancel, and V is nothing but 4 4s are 16. So let's see that V is nothing but 4 4s are 16, right? So it is 16 centimeters from here, but again your answer over here will not be 16, it is from the bottom of the tank, okay. The distance x is taken from the bottom of the tank, so it will be 18 minus 16, which is 2 centimeters, okay. So it is 18 minus 16, so 16 is from this interface, this distance is from the interface, so this distance you are not supposed to report, you are supposed to report the distance from the bottom of the tank, which is this, so 18 minus 16, which is 2, okay. So that's your answer. So if you made it this far, first of all, congratulations. I would say keep working hard, really appreciate your efforts, and I'll see you soon in the next video. This is me signing off today, and I hope you enjoyed it. Keep working hard and keep enjoying physics.